Hey everyone, so I'm going to show you a trick today that will make fractions really easy for you. So this trick that I'm showing you is something I showed to a student recently, and he said, well, I've never thought of it that way, or I've never seen fractions work that way, and it really helped him get a lot of extra questions correct, a lot of extra math questions. And I think this is a great concept to know and to understand because so many people get really frustrated with fractions to the point that they say, I'm not dealing with fractions. I give up on fractions. I don't want anything to do with them. And that is, of course, going to be a little bit limiting. You want to know how to work with these fractions. It'll help you get a lot of questions right, whether it's on, standardized tests or math classes, things like that. So here is the setup that you can use to work really well with pretty complicated fractional expressions. So let's start by thinking of our basic fraction setup here as having four areas. We'll call them four like little pods. There's the top right, and there is the bottom right, and there is the top left, and the bottom left, right? And we'll think about all of these pods as their own contained thing, their own contained unit. It's everything that's up in the top right, everything that's in the bottom right, everything that's in the top left, and everything, you guessed it, that's in the bottom left. And we'll contain those with parentheses. And we'll talk a little more in a second about why I'm doing that. But for now, just contain everything that's in those little pods in parentheses, and we're good to go. So the rule here, the rule that you can use to work really skillfully with these fractions is to know that you can move these little pods along the diagonals. So, right, you could move them like this, right? Up and down this way, or you could move them something like this, up and down this way. Right, so the basic idea is that they can go either direction, right? The top right can go down to the bottom left, or the top left can go down to the bottom right, and vice versa. They can move along the diagonals however they want. Now, what you can't do, what is algebraically not a fair move, it's not a fair game, is you can't move these little pods straight up and down. So you can't do this, and you can't do this either. Neither of those are fair game. Those will make, they'll break our algebraic expression likely. They'll make it invalid. But as long as you're moving along these diagonals, you're good to go. So let me show you an example here of a situation where you might want to use this trick to solve a question that could otherwise feel really, really complicated. So let's pull up this expression here. Or it's actually more than an expression, it's actually a full equation. So looking at this, right, we might have the situation where we get a problem and it says x plus 4 over x plus 3 equals x plus 8 over x plus 5. And it might then say, solve for x. My guess is you've maybe seen some kind of question like that. And if you haven't yet, you likely will one day. So at first glance, this can feel really complicated, right? There's a lot of x's, there's fractions. What do we do? Yikes. But if we use our moving along the diagonal rule, we can make this question much, much simpler. So imagine here that what we do to solve this is move the appropriate little pods, these little factors, along the diagonals. So let's go ahead and move that x plus 3 up and along the diagonal. So it gets to go and it gets to now live with or hang out with our x plus 8. And we can do the same thing with x plus 5. We can move that along the diagonal. It gets to go up here and it gets to live with x plus 4. Now that we have moved these along the diagonals, we have only the number 1 left in the place of these factors or these pods, right? When we move something like this, we want to always remember that once we've removed one of these pods, one of these factors away from one of our quadrants, that quadrant doesn't disappear. It doesn't become zero. It doesn't explode and vanish. It just becomes one. So keep that in mind. That's going to be important down the road. But for now, we know that both of these sides are divided by 1, so those ones aren't doing a whole lot, and we don't need to worry about them. But ultimately, what we have is this expression where we have 2 factors on either side. Both are above our fraction line. So we have, x plus 5, and we have x plus 4, and we have x plus 3, and x plus 8 on the other side. And if we just go ahead and FOIL out those expressions on either side. And if you don't know what foiling is, check out our video here on foiling, because you're going to want to know how to do that for sure when you're working with these types of questions. But we FOIL out our expression just like this. We group like terms, do a little bit of division, a little bit of addition, a little bit of our basic algebra here. And ultimately, we get it down to a solution that x equals -2. So as you can see there, by using this little system of moving our factors or moving our pods here along the diagonals, we're able to make this otherwise really complicated equation into something that we can group, organize, and restructure with just a little bit of like term combination and a little bit of addition, a little bit of subtraction, things like that. So one more thing that I wanted to mention, because it is really important and it's something that confuses students, is that idea that when we move a factor out of its region, out of its little quadrant, that little quadrant doesn't disappear. So this is something all the time where students will take a factor from the top right here and they'll move it down to the bottom left, and they'll say, well, that quadrant's gone, I'm going to move everything up. But that is not the case. We need to remember that whenever we remove one of these factors, one of these little pods from a quadrant, the quadrant does not disappear. It doesn't just shift away. It simply is replaced with, or the new value of that little quadrant is going to be just 1. So we can imagine some scenarios here where we're looking at situations, right? And we're moving around these different numbers, these values, these pods, whatever we want to call them, factors. And we have them moving away from areas, leaving what might seem like nothing there, but we got to remember that it's not, there's not nothing there. There is something there, and it is the number 1. But if you use this system, right, and this way of moving objects, moving these pods, moving these factors, whatever you want to call them, along the diagonals, remembering that when something gets moved out, when everything is moved out of one of our quadrants, we replace it with the number 1. If you understand that, you are going to find all of a sudden that a lot of these really tricky fraction questions that you've often maybe struggled with are going to become not too bad at all. So I hope this is helpful, and I'm excited to see what problems that you're able to solve now that maybe you couldn't before. So let me know, leave a comment below. Tell me what you're able to solve now that you couldn't in the past. If you have any questions, of course, leave those in the comments as well. And I can't wait to see all of the cool math problems that you're able to solve now that you couldn't before. Hello, everyone. So Grantley here. I hope you are loving our videos and feel like you're learning a bunch. And I want to take a second to invite you to check out our ACT Prep app. It's packed with tons of videos, articles, gamified quizzes, everything that you need to do amazing on the ACT. If that sounds interesting to you, check out the link here and you can learn more about the app. And I hope to see you there.